A cluster of earthquakes have started in the Svartsengi Blue Lagoon area related to the Svartsengi volcanic system in the Verkís Peninsula of Iceland. You can see they're at the depth of the less than 1 kilometer, most of them. And they're concentrated along that dike that we have, and probably the eruption site will be there again. We see the earthquake pattern starting from the early morning, then going toward the eastward as the day progresses. This is like a wave moving in that direction. And this is the movement that actually plate movements accommodating through the strike-slip fault lines, the movement from one system, fault line we call them, to the another system, graben fault lines of the, for example, the neighboring Fagradalsfjall, or other ones that are on the map. You can see them here in the Verkís Peninsula, Eurasian, North American plate. You can see again the cluster was coming, and by the midday started and picked up, and by the mid-afternoon it finished almost. But what's the significance of this and what it is showing us? We have to look in the data for the land uplift or land rising, swelling. And it shows that we have now almost passed the threshold. This is the Elfdorf, this is the Svartsengi, a finer one. I will show you also that we have almost reached the threshold or passed it. The Thorbjorn one is interestingly, it doesn't show that. That means before that midday, there was not uplift from the Svartsengi transferred to the Thorbjorn, which is to the slightly to the south of it. So that means the magma was not moving laterally. Now we have the evidence that the magma has moved laterally by these earthquakes. We can look at this data. This is an important chart. It shows how many days passed since the start of the uplift until the lateral movement of the magma starts toward the Sundunga craters. If you look at that, we have the December one, we have the January 2024, and we have the February. And every time it was 5 days sooner starting, because it started from the higher baseline. So it didn't go completely down, the magma uplift. It just stayed at some level. Then again, it started after eruption to gather magma. And after a number of certain days, it starts to move laterally. It's like a tap opening up. It cannot take anymore. It overflows and leads the magma to the side, in this case, Sundunga craters toward the east, and then from there erupts. The red dot at the end of the red line shows what it was just before the morning today. And now with this development, it has really rushed upward. And I predict before the end of the day 20th, since the magma accumulation, which makes it 28th of February or earlier even, we may have it even by the weekend, the end of the weekend. We will see anyway. We have to wait and see. The magma movement laterally as it started, and by the 20th of February or earlier, we may have the eruption. What that means is that now today we know, we have the evidence, I showed it to you, the magma has started laterally to move toward the Sundunga crater series. Anywhere in that line up down to the Grindavík, we may have eruption. So the lateral movement as it started, swelling of the under the Svartsengi will almost reach equilibrium, and then we will have the eruption. This shows also over the several past eruptions how it swells up, then comes down, swells up and comes down. The eruption will be along this line that I'm showing, probably more toward the Sundunga crater, which is slightly to the left. And here again, you see that these are the likely locations that we may have eruption. And even there is a possibility of an eruption in the sea. We will not see it, of course. It will be pillow lavas. People are afraid of that. I don't think there is a reason. We have these examples of them happening already in the sea. We have seen them in Hawaii and elsewhere. Underwater eruptions practically create pillow lavas. And it may shatter the lava in a form of create ash and other things, but it will not add to the explosivity of the reaction. It just the volatiles inside the magma actually cause the expansion and explosivity. Water will not add anything to that. So the likelihood of eruption under sea, we will not see it probably most likely. If you see it, we are lucky. in the Grindavík we may have also, but the likelihood of it is less because the magma has to travel longer to reach there. This is, again, I'm emphasizing, this is practically what we are seeing is a sequence of the ophiolite. And the same things happens. We have the magma source, we have the dark swarm of the darks, and then we have the areas that the magma will erupt.